Now let us study the equations of lines which are parallel to coordinate axis. Now let us consider a simple case in the beginning. That is, suppose we consider a line which is parallel to y-axis and passing through the point 1, 0. Right? So by equation of this particular line, what we mean is, what is the property or what's the relation that is satisfied by coordinates of each point on this particular line. Now let's ask the question, what is common in all the points that lie on this particular yellow line? So the common property is they all have the x coordinate as equal to 1, isn't it? So therefore that's what we write here as x equal to 1. This is what is the equation of the line, which indicates that for every point on this line x coordinate is 1. So from this we can guess what would x equal to 2 indicate. That of course indicates a line which is once again parallel to y-axis but to little right side of the previous line, and now this will pass through the point 2, 0 and so on. So by this we can generalize and say that any line which is parallel to y-axis will have the equation of the form x equal to some constant. Right? So x equal to some constant represents a line parallel to y-axis. Now what will be the equation of y-axis itself? As you can definitely guess, it has to be x equal to 0. And similarly we have the other case, that is, if you consider a line which is parallel to x-axis, it will look something like this. That is, say y equal to 1 or y equal to 2. Right? X-axis itself will be nothing but y equal to 0 or some line below, that is y equal to -1 and so on. Of course it's not mandatory that it has to be y equal to some integer. It could be any fraction or any irrational number also. Basically it's some real constant. So just to summarize, here the equation of a line which is parallel to x-axis will have the equation of the form y equal to some constant. So in both of these cases we want k to be some real number. Right? Now you can definitely sense that every time the line need not be parallel to x or y axis, right? It could be slant also. So what do we do in such cases? Right? For that, let us go over the different forms of the equation of any general line. Alright, firstly we have the 2-point form. That means, suppose we are given 2 points that lie on the line, say x1 y1 and x2 y2. Right? How do we find the equation of a line? So for this, consider a general point, say x, y, and we want to find how x and y coordinates of that point are related. So if we drop a perpendicular from all these points and draw the horizontal lines which are parallel to x-axis, so we see clearly these small triangles. Now you see that the angles which are marked in this, they all are equal because they all are corresponding angles, and each angle is same as equal to the inclination of the line, that is theta. Now from the smaller triangle we can see that tan theta is equal to y2 minus y1 upon x2 minus x1. But if you consider a larger triangle, right? So here if you see a larger triangle like this, now in this case we can write tan theta as the larger opposite side will be nothing but y minus y1 upon the adjacent side which is horizontal below, that will be nothing but x minus x1. And since both of these quantities are basically equal to tan theta, so therefore clearly we can write y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. So that is what we call as the 2-point form of the equation of the line. So what it means is, if you know the 2 points that lie on a line, the equation of the line can be directly written using this form. Now let's see the next form that is called as a slope point form. So as the name indicates, we know the slope of the line and we know one point x1 y1 that lies on the line. So once again let's see a small schematic. Here is a line. We know one point on the line, that is x1 comma y1. The slope of the line is m. Now to get the equation we consider some general point x comma y. Now if we complete the right angle triangle as previous case, we have the theta appearing in that small triangle once again. So slope of the triangle, slope of that line basically is tan theta, which is nothing but m, and this m can be written as the opposite side, that is y minus y1 upon the adjacent side of the theta, that is x minus x1. So hence on cross multiplying we get y minus y1 equal to m into x minus x1. So this is what is the slope point form of the equation of the line. We'll see that x1, y1 and m are the given constants. So at the end only x and y will remain in the equation. Let's go ahead to see another form. Here we have slope intercept form, and by intercept we mean it is the y-intercept. That means we know where the line cuts the y-axis, say at C. Now if C is positive, it means it cuts on positive y-axis. Right? Now the slope of the line is known to us. We consider a general point, say x comma y as usual. Now if we know that it is cutting the y-axis at C, then clearly it means that we know the coordinates of that point where it cuts the y-axis, which are nothing but 0 comma C. And we have seen that now what happens is we have got the 2 points that lie on the line. Of course x comma y is a generic point, and we also been given the slope of the line. So using the formula of slope that we saw earlier, that is slope is nothing but difference of y coordinates, that is y minus c, you see, y coordinates difference upon difference of x coordinates, so that is x minus 0. So therefore here you have m is equal to y minus c upon x. So therefore mx is equal to y minus c, and hence on bringing c on the other side we get y is equal to mx plus c. This is the slope intercept form of the equation of the line. Right. Let's see the next form, which is called as a double intercept form. Now here, as the name suggests, if we are given the x and y intercepts of a line, so that means if we are given where the line cuts the x-axis and y-axis, say A and B, okay, these values are given to us, and once again we have to write the equation of the line. Now if you observe, if we know the 2 intercepts, then that means basically we know the 2 points as a comma 0 and 0 comma b, isn't it? We know their coordinates. So what it means is we know 2 specific points that lie on the line, and we have already seen if we know the 2 points, then we can write the equation of the line in the 2-point form, which is y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. This is what we had seen previously. Now let us assume one of the point arbitrarily as the first point, so called first point, although there is no such order required. So I nominate where is x1 y1 and x2 y2, and let's put these values in the equation. So we have y minus 0 upon x minus a, that equals y2 minus y1, so it is b minus 0 upon 0 minus a. So let us solve this. What do we get is y upon x minus a is equal to b upon minus a. So on cross multiplying we get bx minus ab is equal to minus ay. So therefore transferring the terms we get bx plus ay is equal to ab, and if we divide throughout by ab, then we will get x upon a plus y upon b is equal to 1. So this is what is called as the double intercept form of equation of the line. It is interesting to note that the denominator of x indicates the x-intercept, isn't it? And denominator of y indicates the y-intercept. So that is very easy to remember also.